Simplifying radicals. Now remember, a radical is some form of a root. It just has different numbers on the front depending on what power we have. So for example, if there's no number written, it's an automatic 2, so it's a square root. If we wanted a cube root, we would have put a 3 in front. If we want a fourth root, we put a 4 in front, and so on. So if it's a square root, the idea being, automatic 2, remember, that I have to have 2 of something, the same something, to pull that thing out. So what I like to do to simplify radicals is to build a factor tree. So 8 is the same thing as 2 times 4, and 4 is the same thing as 2 times 2. So if I need 2 things to pull one out, then this pair of 2's becomes out front as one thing, and the leftover 2 stays underneath. So another way to write square root of 8 is to write 2 square roots of 2. Plus, let's break down 12 into our factor tree. Factor tree would be 3 times 4, and the 4 could break down even further into 2 times 2. Well, there are 2 2's, so 1 can come out front. The leftover 3 stays inside. Lastly, square root of 75 breaks down into 5, 5, and 3, because 25 and 3. 2 5's means 1 comes out front. The 3 stays underneath. So looking at these 3 things, to be able to add something together, they have to have the same number under the root. So the 2 square roots of 3 and 5 square roots of 3 can add together to become 7 square roots of 3 for these 2 combined. But this guy doesn't combine. So therefore, our final answer would look something like 2 square root of 2 plus 7 square roots of 3. If, for example, instead of adding, I was multiplying 2 radicals, there's a couple of different rules that apply. So first off, if I multiply 2 radicals, I can multiply what's underneath as long as they have the same number on the root. So since both of these are square roots or they have an untold 2, I can times what's underneath them. So 8 times 4 becomes the square root of 32, and where we have plus 2 square roots of 32, since they have the same number underneath now, we can add them together to have 3 square roots of 32. But square root of 32 is not simplified. Therefore, if we factor tree it, we have 16 times 2, which is 4 times 4. So the 3 stays out front. A pair of 4's brings a 4 out front. And the leftover 2 stays inside. Well, 3 times 4 out front produces a final answer of 12 square roots of 2. Let's try one last example. Square root of 7 times square root of 2 plus 4 minus square roots of 18. So first off, we can times them together because they have the same power or number on the root. So we get square root of 14 plus 4 minus, well, square root of 18, factor tree, is 9 times 2, which is 3 times 3. Pair of 3's means 1 comes out, leftover 2 stays inside. None of the numbers under the radical match, and this doesn't have a radical, therefore none of this can combine, and that would be our final answer.